Hello, I'm Sheshadri Naik from COEPens Academy. In this video, we're going to look at uh, 11th Standard Part 2, Chapter number 6, Exercise number 6.1. There is a question which says whether the given function is injective, surjective or not. So that we are going to solve. There are 5 sub questions. The question looks like this. Okay, check the injectivity and surjectivity of the following functions. There are 5 sub-questions here. In the first 3 sub-questions, the function is the same, which is f of x is equal to x square, but the domain and codomains are different. And the last one, the last two, the function is the same, which is f of x is equal to x cube. Again, the domain and subdomain given are different. So let's start with looking at what exactly do we mean by injective and surjective. So the function is called as one-to-one or injective. In case f of a is equal to f of b, then a is equals to b. That means every member of the domain has a unique image in set B or in codomain. Every member of the domain has a unique image in set B or the codomain. Then this particular function is called as injective. The function is called as onto or surjective if there is no orphan in set B. That means every member of set B or every member of codomain has a pre-image in set A. Then it is called as onto or surjective. So in this light, let's try to solve this particular question. First of all, let's try to understand how do you read this particular notation, which is given here. How do you exactly read this? So function from n to n, from natural numbers to natural number, which is given as f of x is equal to x square. So here, a function with domain as natural numbers and codomain as natural number, which is defined as y is equal to f of x is equal to x square. This is how you read that. So the first one, let's see this particular function, whether it is injective or not. For every member of a natural number, the square is unique. The square is unique. Say, for example, 3 square is 9, 4 square is 16. There's no other natural number which has a square equals to 9. If the domain was an integer or real number, the story is different because minus 3 has the same image as plus 3. Minus 3, the square of minus 3 is 9. The square of 3 is also 9. So there are multiple arrows terminating into the member of set B. In that particular case, it wouldn't be injective. But in this particular case, since the domain and codomain are both natural numbers, only a single arrow will terminate into a member of set B. That's why this particular function is injective. Now let's look at whether this particular function is surjective or not. For numbers like 5, which is a natural number, so it will be there in the codomain. But if you try to check with its pre-image, the pre-image would be root of 5 because f of x is defined as x square. But root 5 is not a natural number. That means there's an orphan of a number like 5 in the codomain. So there's no pre-image associated with number 5 in the domain. Hence, this particular function is not surjective. So let's look at this, the answer of this. So the first one is injective, but it is not surjective. Let's look at the second one, which is defined from integers to integer, given by the same one, f of x is equal to x square. So let's look whether this particular function is injective and or surjective. So the second one is from integer to integer. As discussed earlier, minus 3 and plus 3 will both have the same image, which is plus 9 in the codomain. Since there are two arrows terminating to it, That's why this particular function is not one-to-one. That means it is not injective. It is also not surjective because the same reason as the natural number, root of 5 is not an integer, and that is why this particular function is not surjective. So the answer to question the sub question 2 is that it is not injective, it is not surjective. Let's look at the third one. The third sub question, only thing is that the domain and codomain are real numbers. So let's look at it. So the reason why it is not injective is the same, because minus 3 and plus 3 both are real numbers. They will have the same square, which is plus 9, so it is not injective. Okay, but it is also not surjective, since a number, a negative number like minus 5, its root is not real. It's an imaginary number. Minus 5 is a real number which will be there in the codomain, and it doesn't have a pre-image because that particular pre-image does not belong to a real number. So this particular uh, sub question 3 is neither injective nor surjective. Let's look at the fourth one, which is natural number to natural number. Now the function definition is different. F of x is equal to x cube. So let's look at it. So here, all cubes of natural numbers are unique. So 2 cube is 8, 5 cubes is 125, 4 cube is 64, and so on. Okay, so this particular function is definitely injective. It is not surjective because cube root of 5 is not a natural number. Okay, cube root of 5 is not a natural number. So this particular function is injective but not surjective. So option, the sub question 4, it is injective but it is not surjective. Let's look at the last one, real to real, f of x is equal to x cube. Here um, it will be injective because uh, the cubes of all real numbers are unique. Cubes of all real numbers are unique. All like 2 cube is 8, minus 2 cube is minus 8. So these are unique numbers. Hence this particular function is injective. It is also surjective. It is also surjective because even if you take a negative number, its cube root will be a real number. It is not imaginary. Hence, this particular function is injective as well as surjective. So the final one is it is injective as well as surjective. So this is how you solve this particular question. Um, if you have, so this is the final answer that we just saw. In case you have any questions, if you would like to have more videos like this, you can call us on this number. You can visit our website.